So we have the following theorem that we want to prove. And this theorem is the construction of the quotient group. So we define the quotient set, which is just going to be the left cosets of n, or the quotient of g by the equivalence relation defined by left cosets of n. And so our theorem says that, first of all, g mod n, which is how I read this notation, g mod n. G mod n is a group. The projection map, which takes an element g to its coset gn, this is going to be a surjective morphism. So that's the second thing that this theorem says. And then the last thing is that the kernel of this morphism is exactly n, the normal subgroup that we started out with. So we're going to start the proof in this video, and in particular, we need to show that Gn is a group. So what we're going to do in this video is first we're going to define the law of composition on G mod n. So, and we're going to, so we're going to define this law of composition. So the way that it will work is like this. So we have a coset. So let's say A and B are elements of G. So we have a coset, and that coset is going to be AN, and we have a coset BN, and we need to define AN star BN. And so now this is where, so let's recall some notation that we've used a little bit, which is that of, so we call it maybe product. We'll call it the product set notation, maybe. Set. So that's if we have two sets, S and T, which are subsets of some group G, then the subset ST is, elements of the form ST, where S is in S and T is in T. And so the point being is this product set is just the set of all products. And so this notation is nice. As we've seen before, we can sort of multiply products. We can multiply, sets, which are subsets of a group like this, by things like elements or other sets. And the product set will sort of be what we think it as. So what this is going to be is what we're going to use as our group law is we're going to use AN times BN is going to be the set product, right? So AN BN, right, which is, the set of things times A times N1, B times N2, such that N1, comma, N2 are in N. And so the thing that's important here is that we need to show that this is also a left coset in order to show closure. So how are we going to show that this is also a left coset? And so the way that we're going to do it is we're going to use the product set notation. So we need to maybe say this is a lemma. This is well, so the lemma, this is what the lemma is going to be. AN, BN, this product set, is equal to A times B in the original group N. So that's so if we can show this, AB, this is just an element of the group of G, right? Because we can always multiply two elements. So this will be a coset. This right here will be a coset. And so since that's a coset, then the product set thing has worked. And so the proof of this is, I guess we can prove it. And the proof really takes advantage of two things. One is this notation of product sets and how flexible it is, and the other one is a proposition that we proved in an earlier video. So the idea behind the manipulation is that if I have AN, BN, this is the same thing in the product set notation as A times the set NB times the set N. And if you write down the definitions of these two, it's just this same thing right here. Elements of the form A times N1 times B times N2, such that N1 and N2 are in N. And so now what the important thing that we are going to do is we're going to use this proposition now. So by the proposition, that right coset NB, this is a right coset, this is equal to Bn. This is equal to the coset Bn, and that is because this is by normality. So the proposition we proved shows that this coset being this coset is true if and only if n is normal. And so that's why it's important that the group is the group that we quotient by is normal. This right here is where we use it. We need it to even define what the composition law is going to be. So we really don't have, and because the proposition was an if and only if, right, the implication was two ways. Because it's if and only if we have a non-normal subgroup, this will never be true for all of the cosets. So in that case, we aren't always going to be able to make this. We aren't always going to be able to make this definition be a left coset like we want it to be. So it's very important that the group is normal. That the subgroup N is normal, that is. So we can write this as A times Bn times N, which again, by just looking at the definition of what product sets are, is the same as AB times N times N. And this, N products of things that are in, the subgroup N, well, there's a closure axiom. This is always going to be in N, and by the identity axiom, we might as well put 1 here so we can get all of the elements that are in N. So this is just A, B to the N. Okay, so that is the law of composition on the quotient group.